All right. So hi guys. So let's get started with today's lecture. This lecture is about electromagnetic induction. This is lecture number 3, and today we'll be talking about statically induced EMF. So first of all, let me welcome you guys to the Unacademy JEE English. This, as you know, is a brand new channel by Unacademy, which is India's largest online learning platform for ITJ. And on this particular channel, everything is being taught to you completely in English. All right. So let me introduce myself before moving forward for those of you who might not know me. So my name is Rohit Dixit. I studied mechanical engineering from IIT Delhi, and for almost past 8 years I've been teaching physics for the JEE exam. This teaching so far had been offline, and this is the first time that I'm teaching online here. And offline I've been associated with some of the topmost institutes in the JEE field. I myself was All India rank of 447 and All India rank of 192 in the 2 stages of the IIT JEE exam that I had taken as a student. I also qualified NTSC Stage 2 as a student, and I was in the top 1% in the NSCP. Now, I've already coached many students to top ranks in the JEE exam, both mains and advanced, in the offline setups. Okay, and I hope I can continue guiding you guys to success now in this online setup. So Suraj says, why is the playlist of electromagnetic induction leading to that of thermodynamics? Okay, I don't know. I will find out about that and I will see. Okay, so I had no idea. I don't create playlists. So playlists are created by the Unacademy team. So I will try and figure that out. Okay, I'll talk to those guys. So as I said, before this lockdown, I was also teaching offline. So just like most of you students are used to studying offline. So this lockdown or this new situation forced us to adapt. And that is how I had to move online. And so have a lot of students been forced to adapt and to ensure that your studies can go uninterrupted in even in this lockdown. You can get yourselves the Unacademy subscription. This Unacademy subscription will give you benefits like live classes where you get to interact with your educators on a regular basis. These classes also have live polls and leaderboards which keep them highly interactive. You also have a test series and analysis sessions for that test series. Okay, then of course you have live doubt clearing sessions also, which make sure that your doubts never get piled up. Okay. Next, on top of all these benefits, Unacademy subscription also provides you the opportunity to study from India's best educators from the comfort and safety of your home. So, this is a list of courses that are the ongoing courses on Plus taken by the JEE English team. Okay, so make sure you get your Unacademy subscriptions, and this is how you can enroll in these courses. So, there is a detailed course on graphs, sets, and relations by Abhinav sir. Then there is a course. This is the advanced course on redox and equivalent concept by Rahul sir, and I myself am taking an advanced course on mechanics for class 11 students. Good evening, Shantaji. Okay, and further, there are 4 more courses which are ongoing for 2021 aspirants or class 12 students. So that includes one course by me, which is an advanced course on electromagnetism. Then you have complete course on differential calculus by Abhinav sir. Then you have a course on advanced course on chemical kinetics by Rahul sir, and finally you have a detailed course on optics by Murli sir. So how can you enroll in these courses? Very simple. You will need to get yourselves the Unacademy subscription, and this is how you go about it. So first you need to install the Unacademy app. Once you have done that, go to the plus section of your app, select your goal as IIT JEE, and click on that get subscription button. Okay. Now, when you click on that get subscription button, you'll be redirected to the payment page. This is where you will notice that the fees have been kept very competitive. So any reputed offline coaching setup will charge you anywhere between 4 to 8 times this fees. Okay. And you are getting the same quality education from the same top educators on the Unacademy platform at a very reasonable price. This will become even more attractive if you use this code RDLive. So this is my code if you like my lectures. If you'd like to enroll in my courses, this is the code that you can use and avail a 10% off on all the subscription fees. Alright, so what are you waiting for? Go get yourselves this Unacademy subscription, use this code RDLive, and then all you need to do is click on proceed to pay. Alright, for those of you who are following us on the JEE English channel of the YouTube can connect with us on the Telegram app using this link. So this is the name of the group where you can connect and receive all the notifications of all the sessions and lectures happening on the JEE English channel here. Alright, so why don't we get started with today's lecture? Today we'll be talking about the statically induced EMF. So in the last lecture, we talked about motional EMF and we discussed how motional EMF happens. So we realized whenever a conductor is placed in a magnetic field and whenever this is moving, so all the constituent charges of the conductor are also moving, right? So when we know that when charges placed in a magnetic field start to move, then they experience a force, right, which is given by Q V cross B. So when these constituent charges of the conductor are moving, they are all feeling a force. However, most of the charges are fixed, they are not free to move. But in conductors, there is free electrons. Those free electrons can move. So what happens is this force causes free electrons to move towards the end of the conductor and results in charge accumulation. So in this case, you realize V cross B would have been upwards. So you would have seen positive charges getting collected at one end of this rod. So this end would have had positive charges getting accumulated and the negative charges would have accumulated on the other end. So all this charge accumulation is happening due to the motion of free electrons. That is why you will see that this induction happens only in case of conductors. If you did not have a conductor, if you had a piece of wood, then you wouldn't have had these charges getting accumulated. Now these charges, when they accumulate, they can create their own electric fields, and their electric fields is what is causing the potential difference, or rather an EMF, which is called generating an EMF across the ends of this. Okay, so this is how the electromagnetic induction works. Okay, for motional EMF. So we realize that how to calculate motional EMF in different situations. So as I said, if you have any randomly shaped conductor, so suppose you had a randomly shaped conductor. Okay, so this was moving in a magnetic field, let's say. Okay, so how would you have done that? You would have just connected the ends of this conductor. Just connect the ends of this conductor with a straight line and call this L vector. So this would have been L vector pointing from one end to another. So if you can find this, and if there is a magnetic field which is present in the region, then how do you calculate the induced EMF? Induced EMF would be simply, I hope you remember how we got that. So if the velocity is constant, if the entire conductor is moving with a constant velocity, then the formula was very simple. So let's say this was moving with some velocity v vector. So you would have considered this, replace this by this straight rod moving with v vector, and your EMF across the ends of this would have been v cross b dot L. Okay, I hope you remember this. This is how you'd have calculated the EMF. Okay, so this is one situation where you can find EMF using this. So hello Surendra, how are you? Now for other situations, so we also talked about what if a rod or a conductor is rotating. So suppose a randomly shaped rod was rotating, then how do you calculate the EMF? So let's consider that case. So let's say that again you had some weird shaped conductor like this, and this was hinged at one end and rotating in a magnetic field with some omega. So there was a magnetic field, imagine like this. Okay, and if this was rotating with some omega, then how would you calculate the EMF induced? So let's try and quickly see that. So imagine that this is rotating like this with some omega. Again, what you would do is you would connect the ends of the conductor with a straight line. Okay, so that is how we are always going to approach it. So you should remember, if this was a closed loop, then you realize the flux related to the loop would not have been changing, right? So the net EMF in the closed loop is always zero. So that is the trick that you use. You join the ends, you write it this as L, then you know in this case, so let's call this case number 1. So for case number 1, I have this. This is how you calculate the EMF. If this is case number 2, then in this case, the EMF induced would have been, in case number 2, you already, I hope you remember the expression that we had got. EMF, what was it? Uh, it was B omega L square over 2. Okay, so this is how you would have calculated the EMF across the ends of across the ends A and B of this conductor. Okay, so I hope with these shortcuts and tricks you should not have much problem. I will also tell you another situation I think I had told you in the last class. So which was the most generic question. So what you do is imagine. Sorry. So excuse me, guys. I'm not feeling too well. Okay. So imagine you had a very randomly shaped conductor. Okay. So again, every time you have a randomly shaped conductor, what you do is you join the two ends first. So join the two ends first. Okay. And then imagine that the two ends had some velocities. Okay. And let's call those velocities v1 and v2. Okay. So let's give these guys the ends in some velocity. So let's imagine this was v1 vector and this was v2 vector. So I told you what you do is you resolve this into two components. So we call this v1 perpendicular. We can call this component v1 parallel. So divide the velocity vector into two components. One which is perpendicular to this length L vector, perpendicular to L vector, and this which is parallel to L vector. Okay, so let's call this v1 parallel. Similarly, here also you can divide this into v2 perpendicular, and then you could have had a component which would have been v2 parallel. Right, so in this case, assuming there is a uniform magnetic field, which lies perpendicular to this, okay, so the induced EMF across the ends of my randomly shaped wire, what would that have been? So let's quickly write that. So let's say this is end A and this is end B. So EMF across A and B in situation number 3, that would have been very easy. You would have found this by using the formula BLV average. Okay, this is what you could have found for rotation also. For rotation also, you would have noticed if this is rotating, this end has 0 velocity, this end has omega times L velocity. So the average velocity would have been omega L by 2, right? So average perpendicular velocity would have been omega L by 2. Correct. So that is what you can do here also. EMF induced would have been equal to B L V average. Where what is V average? V average would be the average of the perpendicular components of the velocity. V1 perpendicular plus V2 perpendicular by 2. Assuming that this is a rigid conductor. Okay. So this is how you would have found the EMF across such a situation. So this is the most general situation that I can give you. A randomly shaped wire, one end moving with V1 vector, another end moving with V2 vector. This is the trick that you can use and calculate the EMF across its ends immediately. Okay, I hope everybody followed this. If you have any doubt about this, then let me know. So these are the shortcuts that you can use. Okay. I am hoping you guys followed this. So here is a practice problem for you. Okay. So you've been told a copper wire of length 2 meter is placed perpendicular to the plane of a magnetic field, which is like this. Okay. If it moves with a velocity of 4 I cap plus 6 j cap plus 8 k cap meter per second, find the dynamic EMF across its ends. So this is also called dynamic EMF, by the way. So the EMF that is caused by the motion of the conductor is called dynamically induced EMF, and when the conductor is stationary and then the EMF induced is called the statically induced EMF. So that one is the one which is induced by variable magnetic fields. So let's try and quickly answer this. Okay, let's see if you can figure this out. So how to solve this? All right, how you would have gone about this? Think about this. How will you do this? So is there anyone who's trying? So try this quickly, and let me know your answers. How you would have done that? Okay. So first, can you write the L vector? Can you write the L vector? I hope you realize that we had talked about this, right? What would be the EMF? We had talked about this, that EMF is V cross B dot L. Correct. Okay, so Suraj is trying. All right, good to know. So all you need to do is figure out what L vector is. B vector and V vector you already know. Hello Moisha, how are you? Good to see you after a long time. So how's your college going? How are things? How are studies in college going? So guys, Moisha was a student who was very regular before the last JEE on this channel itself. And I would like to think that I helped Moisha to get a good rank in the JEE Advanced last year. Both mains also, I think. So now Moisha is in college. So, sir, I was trying to catch up with you on Telegram. Okay, were you? So I don't know. I haven't been well actually. So I don't know. Maybe I missed it because of that. I don't know. I don't know if you can figure it out. I have a very bad cold. So I've been just taking some medicines and I've been sleeping it off. So maybe that time. College is fine, better than JEE days. Yes, of course. Of course. All right. So that's great. So trust me, for all you guys also, trust me, this is, if this time seems tough, trust me, at the end of your journey, when you perform well in your exam and when you reach a good college, it'll all be worth it. All right. I can personally guarantee you that. Trust me, all the hard work, all the sacrifices that you make will all be worth it at the end of the day when you're entering a college. I remember the first time, I was going to join IIT Delhi. So I remember the first time I entered IIT Delhi, and it was such an awesome feeling. Okay, that I'm entering the campus of IIT Delhi, and IIT Delhi has a huge campus, by the way. Okay, and it's a beautiful campus. Me and my batchmates, we still sometimes go back and roam around in the campus. It's just too soothing. So trust me, the day you enter that college and you are feeling, wow, I made it. Now I'm a part of this prestigious college. It's all worth it. Have you seen that movie Pursuit of Happiness? I don't know. That is one of my favorite movies. So it is just that kind of feeling that you get, when your dream is achieved after all the hard work. Trust me, you seem to forget about everything that you felt bad while preparing. Every time you felt angry and frustrated while preparing. You forget everything. That nothing matters. We are having our exams online, so fun is fun of cheating outside the proctoring software is fun. Wow. Yeah, I know. This year has been tough for students. Oh. So yeah, so at the end of the movie when he says, okay, this feeling, this part of my life right here, that is what is happiness. So that is the kind of feel that you get when you enter your dream college. Whenever any of your dream comes true. Trust me. So it'll all be worth it. Yes, of course I've watched Forrest Gump. So in IIT we would watch a lot of movies too. So we watched all these movies in IIT only, I think, if I remember correctly. Anyhow, so you have a lot of movies on the LAN, by the way, a lot of stuff. So trust me, life in IIT is not all that scary and all that serious as you may think. It is a lot of fun. All right, so anybody answering this? So first of all, let me tell you what have been told to you. You've been told that a copper wire of length 2 meter is placed perpendicular to the plane of magnetic field. Now you realize the plane of magnetic field is the XY plane. Okay. So since this is the XY plane, so the wire has its length along K cap. Okay. So now can I write the length vector of the wire? So let's write that. So now I can say that since B vector lies in the XY plane, L vector would point along the Z axis, right? So since it has length 2, so I can say that L vector, I am assuming it to be 2k cap. Okay. All right. So now all I need to do is substitute all the values. I know EMF would be equal to V cross B. So V vector was a 4i plus 6j plus 8k. So 4, 6, 8. So let's start writing that. 4i plus 6j plus 8k. Okay, so cross, what do I have? Let's say B vector was 2i plus 4j. So cross 2i plus 4j, and this entire thing with dot of 2k cap. That is what you will get your answer from. Yes, I'm just having cold, no fever. No fever. Just the weather is changing, no. So weather in Delhi is changing. You know the weather in Delhi. You are in Delhi only. So it's changing. So I just got some cold. So that's about it. I don't even step out of my house, so there is not much chance of me catching fever and other infections, that is. But yeah, the changing weather always gives me the cold. So let's try and calculate this. What will this be? So this part would be, so I times minus 32 I. I don't even need to calculate that, but I'm still doing it. So minus 32 I cap, and for j I will have minus 16 j cap, and for k now I have 16 minus 12, so that is 4 plus 4k cap. Okay, and then dot with 2k cap. So this is 8 volt. 8 volt is the answer that I'm looking at. Yes, I know. So it could have been plus or minus 8, both, depending on whether the whether this vector L is pointing in plus I cap or minus I cap, or minus k cap or plus k cap. Okay. So this will be your answer. 8 volt is the correct answer. Okay. Yeah, trust me, I know. I've been in Delhi for a long time myself now. So, all right. So how about this? So here is another practice problem for you guys. I know, and that is horrible. So I am particularly sensitive to the pollution or dust or anything for that matter. The moment there is some dust or pollution, I start feeling bad. Okay, so here is another question. So you've been told a rod PQ of length L is moving uniformly with velocity v parallel to a long straight wire carrying a current I as shown. Okay, you have to calculate the EMF induced across the rod. Take of the value of v as 5 meter per second. the current in the wire as 100 amperes, the R as 1 centimeter, and L as 19. Okay, so what will be R? I think R should be this distance. I think R would be this distance. Oh. So they haven't mentioned what R is. So R I think would be this distance, and obviously that is your length L. Okay, L is 19 centimeter. So try and quickly answer this. So how will you do this? So trust me, motional EMF questions can be very tricky. So get yourself some practice about motional EMF. Okay, it is like asking questions from there because they can form tricky questions on this. Okay, so get yourself some practice. Try this. Sir, I hope to talk to you on a Telegram, and then nothing new to me here. Yeah, of course, of course, of course. So as I said, I haven't been too well. So I have been, I just took some medicines and I've been sleeping it off, trying to sleep off the cold, since at least yesterday evening, I think. So that is why I may have missed your message. Okay, so don't worry. I will get back to you. I know. There's nothing much here for you. You are already in your college. You are already successfully taken your JEE. All right, don't worry. I will in the evening. I will try and respond to you. Okay, and best of luck for your college. Like you always do, Maisha. Yes, thank you for that. Yes. All right. So anybody trying this? How about Suraj? Suraj, are you trying this? Oh, let's just add one thing. So I should just mention here plus minus k. Yeah. All right. So I would like you guys to try this quickly. Bye bye, Maisha. Take care. All right. How about the others? Is anyone trying this? So how would you have done this, by the way? How would you do this? So here you would have had to do some integration, right? Because the B is variable. All right. I hope you remember how to find the E at any distance x. E at any distance x would be such that it would be cancelling out the magnetic force, right? So what is the direction of V? V is like this. The direction of B. The direction of B would be going inside, right? So at the location of the rod, B would be going into the plane. Okay, so B every time is going into the plane like this. With different speeds, different magnitudes, definitely it would grow weaker and weaker as you move away from this wire. But what will be the direction of V cross B? V cross B would be like this. So the charge accumulations you would have seen would have been happening here at this end. You would have had positive charge accumulating, and on the other hand, you would have had negative charges accumulating, right? So that is how the case would have been. So let me know if you are trying, or are you just waiting for me to solve this? So the E here would point in which direction? The induced electric field would be pointing in this direction, right? Because the positive are here and the negative are there. So the E that is caused by this accumulation of charges would be pointing like this, right? So waiting for you to solve. Very nice. Okay, so this is easy. So at a distance x, you know how to find the induced electric field, how to find the electric field that got arise due to charge accumulation. I told you. What is the reason for that? That whenever a static condition would have achieved, this EQ should have been equal to Q V cross B, right? At any point, the force due to the electric field should be able to uh, cancel out the force due to magnetic field. Okay, so at electrostatic condition, you know that the force of the magnetic field would be cancelled out by the force of the electric field which arises due to charge accumulation. Okay, so I can find the E at any distance x. So let's try and find the E here at a distance x. So what is the E at a distance x? Therefore, E at a distance x from the wire, that would be where I'm trying to calculate V cross B. So V and B have 90-degree angles. Okay, so let's write this. Okay, so in the vector form, I'm writing like this. Here, I'm not worrying about the vector form because I know the directions. Okay, and V times B. What will be B? So B would have been mu naught over 2 pi x. Agreed? I also mu naught I over 2 pi x. This is how you calculate the magnetic field due to an infinite wire at a distance x from it. Do you guys agree that this will be the electric field at a distance x? Now you would also know that minus dV over dx would be equal to E. Okay, I hope you remember this also. Yes, at electrostatic condition when the charge accumulation has stopped. So initially the charges will start accumulating, no, and then a certain amount of charge would have accumulated, and then that will continue. No more charges will accumulate. I had told you this when I was explaining motional EMF, that due to the magnetic force, the charges start accumulating here, This charge accumulation stops when the electric force is able to cancel out the magnetic force. So that is when you would have had the complete charge accumulation, or I can say at electrostatic condition. Okay, did you get that? Yes. So now you use this. You already knew this. So all you need to do is integrate this. So can you solve it from here? Okay. All right. So here I am. So let's just find the answer. So delta V or VA minus VB would have been mu naught I over 2 pi V times ln of x, and x would have ranged from 1 to 20. Okay, this is how you would have said. So let's call this A. Let's call this B. So this is what you would have gotten. So here you would have integrated V from A to B. So that would have given you VB minus VA. But I have taken the minus sign also. So I'm writing VA minus VB. And this is how you would have gotten it. So this is the answer that you should have had. So mu naught I V over 2 pi ln 20. Okay, this is the answer. Now all you need to do is substitute these values. Okay, V was 5, I was 100. So, okay, let's start substituting. And ln 20, I don't know, they should have given ln 20 also. So substitute the values and you can find the answer. Okay, this is another problem that I would like you to do as homework. Okay, because we are almost running out of time. So this is one problem I would want you to try as homework. Okay, So this says two long parallel wires of zero resistance are connected with each other by a battery of 1 volt. As you can see here, the separation between the wires. Okay, so this is not electromagnetic induction, in fact, is it? Huh. Okay, I think this is okay. So try and do this as your homework problem. Now I will move and introduce statically induced EMF, which was meant to be the topic of the day. Okay, so we have wasted a lot of time discussing other things. So whenever a stationary conductor is placed in a time-varying magnetic field, the EMF induced across its ends, EMF is induced across its ends, and this EMF is what we call statically induced EMF. So when I say statically means the EMF induced in a conductor which is at rest. Okay, so this conductor is at rest, but the B is varying. So if B is varying, you realize that a current starts to flow in this conductor. So how is this happening? So first of all, let's talk about the Faraday's equation of the induced EMF. That is going to be very, very simple. E would be minus d phi by dt. So again, if area is constant, then you would have had A times dB over dt. Okay, minus times. This would have been your NAB. That would have been your magnetic flux. Okay, so this is the answer that you would have gotten, and we will usually always assume that the area is constant. Okay, area of cross section is constant. Okay, so this is how you would have calculated this EMF. Okay, so if the magnetic field starts changing with respect to time, then there is an EMF that gets induced. A of wire is constant. So this is the equation that I have that I'll use to solve my problems. Now let's try and take a closer look and try and explain why this is happening. So why is the statically induced EMF coming into play? So the only explanation that we can think of is that when the magnetic field changes with respect to time, that is whether it increases or decreases, it could have been anything. There is an induced electric field in the conductor caused by changing magnetic flux. So every time the magnetic field flux is changing, so you need to remember that changing magnetic flux induces electric fields. So electric fields have two sources now. One, obviously, charges can produce electric fields. Second, time varying magnetic fields can also induce electric fields, or they can create electric fields. And it is those electric fields that are causing this EMF. All right. So that is our explanation for this. The induced field is such that the line integral along the closed path is not zero. So when a charge of Q goes once around the loop, the total work done by the electric field is equal to Q times the EMF. So you can realize that the induced electric field I am proposing is such that integral E dot dl should be equal to EMF. Okay, because this electric field is causing the EMF. So EMF I know is the work done by the driving force in the entire loop. So closed integral of E dl, because this is the work done on unit charge. So this is how I can find how much electric field is getting induced. So first thing is time varying magnetic fields induce time varying magnetic fields induce electric fields, or they can create electric fields. Okay, so that's the idea behind explanation. Okay, now let's take a closer look on what is the nature of these electric fields. So nature of the induced electric fields is such that one, they are non-conservative in nature. They almost form closed loops. They have to form closed loops like this because think about it. If they did not form closed loops, if I told you that the electric field here had a component which was radial also. So I suppose that everywhere the field was like this, assuming hypothetically, then this would have had a component like this also. Then that would have violated Gauss theorem. Okay, I hope you realize that for the volume bound inside, there would have been a flux coming out of the volume when there is no charge enclosed. So this cannot happen. So this field can never have a component like this. So this entire field has to be always tangential, okay, to the loop, and has to form a closed loop. So closed circles they form. Okay, they are circular electric fields in nature, which is very opposite. Okay, in case of charges, you find electric fields which extend up to infinity and they never form closed loops. This is quite opposite of that. Okay, so you need to remember this, right? They form closed loops, very strange nature. Now the relation F equals QE is still valid for this field also because they are electric fields, so they will still apply a force like this. The concept of potential has no meaning for this. Why? Because that is only defined for conservative fields. Okay, so please remember you cannot define a potential for this. Okay, now the induced EMF due to this field between 2 points depends on the path also. So earlier you knew the potential difference between 2 points does not depend on the path. Okay, while the induced EMF due to this field will depend on the path. Why? This is non-conservative in nature. So the work done by this field will be path dependent. Okay, and that is how we define EMF. Okay, so this is basic introduction of your electromagnetic induction due to statically induced EMF. Okay, so here is a practice problem, very simple practice problem. I would want you guys to try this as your homework, and we will discuss this in the next class. Or we will discuss more problems in the next class. You can try this as your homework. Okay, you can leave your answers in the comment section also. So you've been told a magnetic field at all points within a cylindrical region whose cross-section is indicated in the figure starts increasing at a constant rate of alpha Tesla per second. So magnetic field in this cylindrical region is increasing at a constant rate of alpha. You have to find the magnitude of electric field as a function of small r, which is the distance from the axis of the cylinder, for 2 points, one lying inside and another lying outside the cylinder. So this is one very standard kind of problem. Try this as your homework, and we will discuss this in the next class. Okay, so this is where I would like to wrap up today's session, because I'm sure you guys need to go to Abhinav sir's class. So next time we will take up some problems also, and in the next class then we will also start our discussion on self induction and mutual induction. Okay, so before I take your leave, let me remind you that this is how you can get your Unacademy subscriptions if you haven't gotten them already. Go to the plus section of your app, select your goal as IIT JEE, and click on the Get Subscription button. Okay, and when you click on Get Subscription, you will be redirected to the payment page where you will be asked a code to get a discount. So that is where you can use this code RDLive and get a 10% off on all these already very competitively priced subscription plans. Okay. Now, when you enroll, when you get your Unacademy subscriptions, then these are the courses that are being held by the JEE English team on the Unacademy Plus. This is where you can enroll for your JEE preparation. Okay, so I myself am taking an advanced course in mechanics, and there are two other courses by Rahul sir and Abhinav sir. These are class 11th courses. Then you have 4 courses for class 12th topics. Okay, so including an advanced course on electromagnetism by myself. Now, if you like today's video, then don't forget to press the like button and try and share it with as many people as you can. Okay, as I keep saying, for those of you who can't afford this subscription, should definitely at least follow this channel on YouTube. So you are already getting free quality content. Okay, so if you can't afford that subscription, get the help that we are offering free. Okay, so make sure that you are spreading the knowledge and sharing it with all your friends. Now, don't forget to press the bell icon, and the PDF of all the slides used in today's lecture would be available for download very soon. Again, those of you following us on the JEE English channel can connect with us on the Telegram app using this link. Alright. So one last time before I leave, this is my code RDLive. So if you want to get, or if you're planning to get your Unacademy subscriptions, this is the code that you can use. RDLive, and get a 10% off on your next subscription. Alright, so that is it from my side, guys. So I'll see you later then, and till then you guys take care and keep studying hard.